Yeah, you're audible.
Job, you can please start.
Yes, sir. Yes, sir. Dear members, the Indian Institute of Foundrymen, Southern Region and Chennai chapter jointly organizing non-ferrous technical webinar today on the topic PDC casting quality casting quality enhancement through hydraulic oils and dye cooling waters. And it is fortunate the topic also chillers and the climate also we find very cool. And I take this opportunity to introduce the guest of speaker for today, N. Prabakaran sir from Dytech. N. Prabakaran sir graduated in mechanical engineering during 1979 at Government College of Engineering, Coimbatore. He got experience from Union Company Motors, Chennai, Vishak Industry, Coimbatore, and Sundaram Clayton, Chennai. And he played a major role in introducing and implementing new process like SMED in pressure die casting. He found Dytech and in the year 1995, Private Limited. Engineering excellence with innovation thinking system and latest technologies was his motto. And N. Prabakaran sir believes in systems and teamwork, which is the foundation for an organization. Under his leadership, Dytech evolved many techniques in manufacturing die castings, dies with high-tech equipment. Cell concept was introduced by him to give more attention to requirements on customer by manufacturing team. Mr. Prabakaran sir has a vast 40 years of experience in die casting field and established a modernized tool room at Sri Perambatoor in the year 2011 with 300 employees in 1.5 acres of space. Dytech India is leading tool maker for high pressure die casting, low pressure and gravity die casting. Dytech is capable of manufacturing HBDC dies ranging from 250 ton to 2200 tons gravity die castings for up to 20 kgs. And the major customers are TVS, SM, Maruti, Honda, Yamaha, SCL, Ashley, Bosch, Wapco, Sunbeam, and Regal, Boltec, etc. He is the only successful businessman, but not noted speaker on gating techniques, cooling system in die, and latest techniques about manufacturing at various presentation in Alucas, Tagma, ISLZ. And the floor is yours, sir. And it is my privilege to introduce you to the webinar today. Thank you.
Thank you. Good afternoon to everybody. We'll start.
Good afternoon, sir.
Good afternoon, sir.
Is it audible and screen is okay? Hello?
Yes, sir. You're audible on the screen. We can see the screen, sir.
Yeah, sir.
Yes,
Okay.
yes.
Okay, sir. Visible.
I will start. Yeah, sir. Probably today we have taken a topic PDC casting quality enhancement through chillers. The chillers are divided into two. There is one hydraulic and hydraulic oil chiller and die cooling chiller. Okay, normally, by enhancing that facility, today market scenario is a cost competitiveness. This is what people are not, commonly these are all getting rejected or otherwise you could not be able to implement because of the costing which was not made by customers. This is a real challenge in die casting. Even when we started die casting, when I am starting probably by 80s, I am telling that the PDC machine, the casting will be produced with the PDC machine, one furnace, one water tank. This is a facility what we started probably 80s, I am talking about it. But there the casting formation is most important, finish is important, not other even X-ray is not very much popularized at that time. And even what we called of the different alloys, what we developed, advanced alloys are not available on the 80s, what I'm talking about. Normally you used to talk about LM24 and LM6. But today the varieties of alloys are available to cope up with the engineering requirements of components like automobile or any other sections. But there is a challenge is there for costing competitiveness. But the aluminum components requirement is abundant. It is going to be very high and within what we are expecting 4 to 5 years, coming years, what we are expecting because of Europe export. Probably some US will be stuck will be there, but there is a lot of export for other countries like Europe. And even that the Indian requirement is also going up. Probably you know that Maruti is going more and more plants. Even Gujarat, they are planning for a bigger plant. So these are all the expansion when we are seeing that honorable line is going in a different fashion. So 100% what we expect the aluminum casting requirements will be more. Yes, there is a cost competition is there. How to approach this problem? That's the first we want to go into that. Probably that is why the topic is chosen in such a way. There is a justification for this topic, what I am going to talk about it. Probably how to approach means now we will have to get ourselves is ready to present a good quality castings to the customers. Probably if we are not getting it ready, then we cannot ask for the more cost or what will be, how they can judge if you are asking for a cost increase, how they will judge. Probably you will have to present, yes, the my quality is something around probably low rejections level and then commitment to delivery. And the facility, what we are talking about, previously what you used to say that normally today, the concept is in a production, they are expecting the process. If you are setting up a die casting plant, they are expecting there will be 3P will be always applied. There is one is a prediction, another is a prevention, another is a poke. If you are start doing the die casting process, these three are all very, very important. How we can do that today, the simulations are available so that we can predict the problems and take countermeasures or whatever the preventive actions will be taken. And what we called as a poke, there only the facility is coming. The facility-oriented die casting is really required for the process. What I am talking about the facility, what I am talking about the process, then the facility has to be concentrated on the like what we are calling of the chillers or what we were talking about the dye heating oil or what we were talking the vacuum, everything will be facilitation should be given. In the 80s, probably I have got an experience. One die caster will give a good output with less rejections. Another shift, there will be a problem. Then another die caster will be a different, it will be a medium size, or whether you will give a less output or more quality. Certain people will give a low. So what it shows, there is a skill-based die casting was run in the 80s. It is not a poke process or something like that. How we can create a poke on the process means we will have to make more and more facility to the die casting machine, see that the castings are coming what we expected quality. This is a challenge here, but there will be some cost justification also I am trying to give for the chillers. Whether if we could able to feasible to with the existing costing factor, whether it is feasible, I'll give some costing structure also at the end of it. So apart from that, what I am talking about it, attracting the customer towards that is most important to get your costing expectation. Probably we will have to present a casting shop floor in a very different way. Probably with the 5 years and then visuals and everything will be placed inside the shop floor, and your process will be transparent to the root level. So if we could be able to do all these things, probably customer will be attracted. Apart from that, process control evidence, probably we'll have to start using that IoT. Probably die casting should have the IoT to get back, or otherwise you can say each and every casting will be identified through a QR code engraving. Probably each casting, the process parameters stored through IoT to ERP so that we can detect any problem, even if it is in later, we can predict what it has happened in the process or something like that. In the process, apart from that, we can see achievement of less rejections. Probably we have to show some evidence what my rejection level in my shop floor. Probably if you could be able to show all these things in front of the customers, yes, probably the customers will be what I am expecting. We'll have to do that, then only they can able to provide the considerations of the casting. So what I used to do that, we will provide and then we will ask for the cost. Probably that approach probably will make you that cost competitiveness will be met. Now we will start going into that. This subject, probably there is a lot of casting defect. There will be a lot of probably the machine is there, and then alloy is there, and then there's a time is there, and then mold is there, and then machine is there. So all the elements will be going to create a rejections defect. What we are talking about is the temperature, the cooling method, and then filling pressure and boost pressure package. These are all the areas which we are going to concentrate through dye chillers and oil chillers. In turn, reduce the rejections level from these elements. Now I have presented this slide where I am going to, which area I am going to cover the rejections of reduction through dye chillers and oil chillers. Probably I will present in this way. Probably we will start the cycle at a temperature of 100 degree. Probably we will warm-up shots will make rejected by 10 numbers. From there, it will be first past approved stage. Probably the dye temperature is reaching from 10 to 200 degree. That may be the 200 degree, what I'm giving one reference. According to the casting configuration and other factors, it will vary. Probably I have taken a 200 degree as a reference. So that stage from after warm-up shots, second stage is around nearly first part approval stage. That also 10 to 50 cycles. From that 50 cycles, I'm assuming that process parameters are settled and then casting is giving a whatever the minimum percentage, 3 to 4% or 5% rejections is coming into that. After that, there will be a start and stop stages there. That's also included in the production stage itself. Probably if your start and stop is very less time, probably it will not be drop down the 200 degrees centigrade. And then we can take the further cycles will go. What the dye chiller is going to play a role on reduction of casting in the production running stage. That is a second stage and probably third stage and fourth stage. What I am talking about, you can see that. This stage and this stage is going to take about, even precisely saying this stage is going to, what we are talking about the reduction, the production running at this required temperature. This is what I am going to deal with that. So probably what you can see, even I have given some comments in the below. Overall rejections, probably 10, okay. 10 is also rejections if you consider it's okay. That is a warm-up charge. First part approval stage, probably that will be around 50 cycles. So altogether, if we see that, suppose if a shift is producing around nearly 500 or 400, probably it will come around 10% of the casting. We don't have any answer for the warm-up shots and first shot approval in this dye chiller and oil chiller. But there is a solution is that if we could be able to provide a dye heating oil, this can be tackled. This rejection can be tackled through a rejections by dye heating oil system inside the dye. And even that start and stop of stage also will have a less only, probably since being that very short time, probably if you stop, probably there another 30 to 40 hours will be less. And then once again, the dye temperature will be picked up. Now, normally one more identity. These are all the inputs for further slides. So the dye temperature, if I'm doing a through a thermograph, normally the high dye temperature lies with the screw boots and the spreader. Even one more clue also I'll give that. If you want to increase the productivity, you want to reduce the cycling time. Even we can measure the biscuit temperature tackling. Probably will improve the cycle time. Normally we used to talk about that casting temperature. Rather than we can take into account of biscuit temperature reduction will be one of the way to go into the productivity reduction of the cycle time. Normally these two zones are all very high. Very high temperature will be always there in any dye if you are talking about. Through and spreader is the most highest temperature in the dye. So normally why I'm putting this table in front of you. This is analysis what we could able to say 80% of the rejections almost coming on to porosity. Porosity is divided into two stages. Probably one is air porosity, another is a shrinkage porosity. Apart from that, some rejections are that we will be always calling, you can see all blue highlighted, all are related to temperature. almost low RI. These are all related to temperature like crack and RTA. This will be very rare normally. Solder will be a common phenomena. Once again, the low dye temperature. Surface defect is also related to low dye temperature. Core pin failure also high core pin temperature. So if we could be able to see all our thermal oriented problems. So if we could be able to tackle this temperature oriented problem, probably we will reduce the rejections in line. So probably I have given some system also, probably that the porosity of gas, I have given a vacuum. So we don't have any answer through dye temperature or oil temperature reduction. These are all will not going to help. But porosity in gas, air porosity can be tackled by vacuum. What I am saying that the facility what you are going to embed in the machine, probably will have a solution. If the solution is there, then operation will be taking care of the rejection control. Previously, what I am saying that before 20 years back, probably we will deal with only operators level, how they can able to do it, and then more tackling on only metal side by degassing this and that, but without knowing what is inside the air. Probably you know very well between after pouring saucily to dye, probably near to the dye runner, probably a lot of gas will be created. That is also going into the, if it is going in front of the cavity, front of the air, front of the flow, then it will get escape. Suppose if it is getting turbulent inside that, once again the casting resistance due to gas porosity will come. Now we are going to concentrate on only the shrinkage porosity, which how we can help the machine to not to create a shrinkage porosity. Now, this is what root cause and other things. Okay, these are all additional points what I'm going to, what I am saying that probably people will think I'm going to discuss about the total rejection reduction and all that. No, it is not so. My purview is only shrinkage related casting defect, how we can reduce it. This is only the essence of this paper. Probably I'm highlighting to, yes, I am going to that direction. So I am highlighting to all other directions which is not dealt here. That's what I am putting this slide also. The discussion topic related to cooling only. This is only a concurrent for first phase, second phase. Okay, poor position of the die, poorly designed. One more thing, what I am talking about, the proper die design. So this is going to be a big subject. Probably how the die can be designed in such a way, less rejections can be produced. Or the today requirement is almost a nil rejection. That is approach what the die design has to go into that way of direction. How the die can produce a nil rejections if the process parameters are well controlled in the process. Probably this is a combination of die design and the process of die casting. Probably both should work in such a way that it should reach the minimum rejections, what I can say. Even we'll have to have the target of nil rejections. So probably this will be eye opener for in a die casting, what I am saying that. Now conventional die casting, what will be the cooling systems? Normally there will be a tower cooling, maybe a DM water or it is a groundwater, whatever you say. But normally today, I think all the die casting shop floor was converted to DM water. So probably I am also strongly recommending to go for a DM water because of the scaling effect can be reduced both in die and heat exchanger. So tower cooling, this tower cooling will be both. One temperature will be maintained according to the cycle. The tower cooling, water cooling temperature will go up or down, depends upon the number of cycles what you are running. From the pump and as well as the die will start eating the water. This water, this is a common water flow from the tower cooling. It will go to the die, heat exchanger also, machine heat exchanger as well as the die. So if the temperature goes up, both will be get affected. Die is also getting affected and water. Probably die, it may help for the die, but oil it will never help. When you're starting the cycle, immediately the oil will get heated. But probably we are trying to maintain around 40, 45 or 48. Even probably people are working up to 45 to 48 degrees centigrade in oil. Probably what is the effect on that? I'll show you that one or two slides later. So now you have to understand here, a common water is used for oil cooling and as well as a die cooling. So if the effect is, if water rises, oil temperature also will rises and as well as die temperature also rises. So this is the old system, conventional, what we are going to have that. And also I told you the last point, it is inevitable to control individually hydraulic oil temperature with a common tower cooling system. This point is very valid. Anyway, I'll give a further comments on that. See that further what I can say, further details I can share with you. What is the importance on the oil temperature maintenance? This is improved cooling system. What I want to show, there will be one oil chiller will be there and dye chiller will be there. Probably there is a small error is there. So oil chiller, this is the dye chiller. So dye chiller will take place on dye and oil chiller will take place on the oil. So it is separated out now. The total oil heat exchanger is removed. In a chiller, directly the media is oil and then going and then coming out. No water is inside here. It's only directly oil will be taken to chiller and then getting into the oil tank. So constantly we will maintain the temperature, whatever you want, 35 or 40, whatever you are talking about it. Based on your requirement, we can maintain it. This dye temperature is no way connected with the oil temperature. This is the best advantage. And what are the of separating out the chillers? This is a water chiller, this is oil chiller. Now, I told you what could be happen in oil. What you can see here, there will be almost a 45-degree slope is there for this. If a temperature goes, your viscosity will go up. Nothing but a viscous is reduced. So when the viscous is reduced, you know very well, the pressure drop will be more because of the viscous is reducing or viscous number is more. Your thinness will be more than your pressure drop will be more. Almost you can say 45 degrees. The slope is very high. Suppose the slope is around only 10 to 10 degrees, there is no much value. But when I'm seeing the pressure drop by curve, which is given in the net, what they are talking about nearly 45 degree means it's equal. Whatever be the problem here, this will be transferred in the pressure drop. So now we can see 10 degree if you are raising that oil temperature, your injection consistency will also vary from 10 degree. Suppose certain castings we need not have even much sensitivity on injection side, but most of the castings, I'm talking about 60 to 70% of the casting, we could able to maintain the injection consistency, injection force consistency equally, then you will be the constant, whatever the casting produced will be a consistent in quality. So this is a very, very important. Should have to give that viscous, retaining the viscous of the oil, so that pressure drop will not be there, and as well as you will get the consistency in the injection force. Now another functions what I am talking about, it is through a closed loop replication system. So what I am saying closed loop means no pollution will take place in between the chiller, between oil and so everything is closed loop. So that will be the big advantage. There also is a closed loop, but it is through exchanger it is there. But in water cooling only we used to have a lot of pollution it used to happen. But you know very well today what the problem they are facing in heat exchanger. The cleaning or maintenance is very high because every 3 months or 6 months they have to be cleaned. Otherwise, the oil temperature will go up. All these problems are today existing in a conventional die casting machines. Conventional cooling system, what I can say, even conventional cooling system and conventional die casting, rather we can say conventional cooling systems will have this problem. And hydraulic oil circulates under pressure. That's another big advantage. It absorbs frictional and mechanical heat. If you're using the hydraulic oil chiller, it will be pumped with a little pressure, 2 bar or 3 bar, because another pump is running inside. So it absorbs frictional and mechanical heat. And ensuring oil retains the designed viscosity, lubricant property. That is ensuring oil. This is the advantage of that chiller. I'm talking about the oil chiller. Maintain the ideal temperature typically between 20 to 35 degrees. And this is possible. Even if we can bring down the below the atmospheric temperature, that's also possible. Suppose we want to feel that even 5% or 10% injection force, you can slightly increase 2 or 3% injection force. Consistently, if you want more, then we can think of even reducing the oil temperature and taking more force inside. But the percentage will be very, very less, negligible percent, probably 1 or 2% we want to increase, that we can increase by reducing the temperature of the oil so that we can retain the more viscosity. The pressure drop will be very, very less. The result is only by reducing the oil temperature to the 20 degree. you will get the reducing the pressure drop, so that injection consistency will be maintained. Reduce pressure drop because of the temperature and retaining oil viscosity. Injection velocity, pressure consistency. These are all the hydraulic chillers functions. Now, add-on advantages. There's more. If you start using that oil, oil chiller, a leakage will be totally. When compared to conventional without a chiller and with a chiller, you will have leakage problem will be reduced a lot. Since the oil temperature is not reaching more, consistently it will be maintained by 35 to 35 degree. Your oil seals will not have any temperature effect. Your leakage sealing will be better, so leakage will be less. And then excessive wear and pumps. So you know that pumps is also depends upon. Suppose the pressure drop is there, the van pumps are all getting slip, the wear and tear will be more. Probably that excessive wear and pumps will be life will be more. And seals and walls always will have a better life. These are all the add-on advantage. And stable hydraulic oil temperature is a clamping pressure. This is another advantage. If you could have the same hydraulic oil is used in locking pressure also, probably in die closing cylinder. So if we could be able to maintain that oil viscosity, probably clamping pressure will be consistent. So this is another advantage, add-on advantages. And then normally you can reduce the energy of the pump. Probably we will end up with, if you could be able to maintain the oil temperature, your energy losses will be minimum, so that your current rating will be less, so that your power requirement will be probably, these are all probably 1 or 2%. Not, I am not saying that it will be very big thing, but there will be reduction will be there. That is what I want to say there. Selecting the right oil chiller, yes, this is very, very important. Probably we will have to talk about the supplier, what your requirement of. Suppose today, we are all getting from the, we will used to say, this is the machine, what I'm going to use it. Probably they will tell the spec, what you will have to use it. So probably we'll have to take the input from that. Buying the chiller is not very important. And since you how much heat you are going to extract for that particular, how much pump it is running, pump capacity. So all these things will be taken into account, so that the chiller can be rightly selected. And according to need to do okay. Next, oil grade compatibility, probably viscosity range effectively. So the oil, the chiller should have the capability of retaining the viscosity range effectively. And then one more thing, you should use a digital controllers for that temperature reading and even maintaining the what I can say, that refrigeration system and all that. And then environmental, okay, that is one more zero. Probably we'll have to talk about that oil, what we are using it, whether the refrigeration system is also should have the zero ozone depreciation. What I'm saying that these are all the ESG norms. But we cannot use any refrigerant what you like it. So there is a ESG norms, it's their environmental governance. So based on that, they will select the refrigeration. And insulation type. Yeah. Now what I am saying that decide between a standalone and centralized. The two options are two machines. I will have one chiller and one oil chiller, or otherwise I will have one chiller for die chiller for both heat exchanger and as well as die cooling. So these are all the combination of selection is there. Normally I used to recommend only go for a standalone, because it will not have it. One breakdown is that all other machines will have a problem. So probably we will have one replacement already. If your standby is there, then we can use that replacement, and immediately we can start the production. So normally it is better to have each and every machine have individual, but according to cost and our investment capability, we can select according to your requirement. Oh, this is a மேல இல்லையா இது திருப்பிங்க இது ரிலேட் பண்ணணும் நெட்டிங் போயிடுதுன்றான். ஞாபகம் போகிறோம். So now we will be going to the water chillers. What will happen if you are, what are all the functions of water chillers in a dies? Prices and thermal regulation of die cavity, which is essential for uniform solidification of the molten metal. Defects, yes, reduces shrinkage porosity up to 70%. These are all already done some experiment, and then they found, yes, shrinkage porosity is the major. Next is air porosity, but this can be tackled up to 70%. We can tackle through a die chiller. And then normally, since we are maintaining the dye temperature, probably it will not go to the high temperatures. Oh, but one thing, water chillers is having two functions. One is a temperature maintenance. Whatever be the temperature you are sending it inside, that will be processed for your outlet temperature. Probably you can talk about 30 if you want to maintain, or 25 if you want to maintain. So whatever be the input temperature, this will be the energy, whatever the inside it into liquid, that will be absorbed by the refrigerant, and you will get the output of 25 to 30 degrees. That's one advantage. Second, in dye chiller, one more advantage is you can give a pressure. You can go 2 bar or 3 bar or up to 5 bar, you can able to send the water inside the dye. So this is another advantage, sir. But anyway, we will talk about how to use the dye chiller in a dye. That is another big topic is that I am going to deal with that later. Third one, the prevents warpage. Okay, surface quality almost, if you're able to maintain that surface temperature of the dye, then you will get a better surface finish. And one more thing, what I am talking about the X-ray, it promotes the X-ray quality more. That is what the main advantage of that one. Because of the density and the reduced porosity of shrinkage porosity, then it will improve the X-ray quality. Yes. Add-on advantage of a water chillers. Yeah, okay, reduce the certification time by 30%. That is very, very attractive, and also people have started using it by way of increasing the productivity by way of reducing the cycle time. This is a one way what we are talking about it, the reducing the cycle time. I'll put that now. We will talk about this subject probably after the end of this one. And the enhanced material quality, as it is the refined grain size and increasing tensile, these are all the additional advantage. And then extend the dye life. Since you are maintaining the equal, almost near and plus or minus 20-25 degree, probably your dye life will be more. Now we'll talk about the reduce certification by 30%. Now I'll go to that before slide. Yes. Now we'll put that our thinking in this way. This zone is very high, and this zone is very high. All other areas. What it means, I need more cooling here and more cooling here, and then these are all the lesser cooling. This is a challenge. Suppose if I'm using the regular water cooling, I'll give some water here, and then I'll give water. So whatever be the heat extraction will be common for everyone. Probably by adding a number of cooling lines, it will be little managed. Suppose you start using that dye chiller. From the dye chiller, we can have a more flow here by way of giving a more pipe and increasing the pressure by 3 to 4 bar. If we're increasing it, this will be taken care, both the through boost and spreader. But at the same time, this area will get more cool. This is another problem. Suppose if I'm increasing the flow and as well as the pressure here by way of even reducing the inflow temperature, the challenge is how to maintain this area. This is a big criteria. What I am saying that when we start using the dye chiller, you should have a timer cooling and jet cooling, and as well as a different orifice. So you got a three way of tackling that flow by way of timer cooling and as well as jet cooling and as well as the continuous cooling. You will have continuous cooling. Apart from the continuous cooling, you should have a different orifice, say half an inch or quarter inch. According to where you will have to put in the dye, according to temperature, you will have to reduce the port. What I am talking about, to reduce the port inside the manifold. So by way of this, if you are giving start giving that a timer cooling, if you are giving a continuous cooling here, yes, there will be heat extraction will be more. If you start using the jet cooling here, a little temperature will get up. If you're using the timer cooling here, the temperature will be retained. So it is possible to using the dye chiller, we can reduce the temperature in the biscuit so that you will have a higher productivity and also uniform temperature around the dye. There's one more question is coming. Why can't you do it in the existing systems? Why it is not private? What is the existing system? We don't have the reduction of temperature of water inside. Dye chiller only create a reduction of temperature inside the water and as well increase the pressure. That is also not possible in the conventional tower cooling systems. Here we can increase the water input and as well as the dye management by way of giving the timer cooling and the jet cooling in this area, so that we can use the dye chiller effectively by having these systems in the machine. This is what my dye chiller, there is a problem will be there, how to manage the dye chiller in a different way. This is what my explanation on this. This is add-on advantage, reducing the cycle time, already grind size and extended dye life. What I told is what I explained now, what I am saying that how to manage the dye chiller with a dye thermal balancing by way of having a timer cooling, a jet cooling, and then continuous cooling with the flow rate control. Probably these three will be able to help in retaining the temperature in the. So just blindly putting into the dye chiller inside the dye will not help. So you should have the system of this also. Then only the real advantage you will really get it on dye, and as well as the dye chiller will give an effective result. Probably now I am putting that cool and hot zone of throughput and spreader runner part of the dye will have a more flow with the low high pressure and as well as more flow, high pressure and low temperature of the water. This area will have a control on timer cooling with the timer cooling with the flow rate control and as well as the jet cooling. Probably we will be able to maintain the thermal balancing. Now we know how there will be a big problem in everywhere. How to maintain all these equipments nearing the machine and then maintaining it. There's a big issue, and then, so probably we found one layout. What we have recently we developed on die casting plan, and we started using this layout. What we did it, a machine will be there, and one more that casting trolley will be there, casting conveyor will be there. Probably we'll have a pick mat here and all that. So there will be trimming press is there near to that. So these are all in the ground. All other equipment should be lifted above 1.5 meters or 2 meters. Like what all mean is the oil chiller, there is a dye chiller, there is a heating line, and even there is a vacuum line and heating line. We can have an air tank here, air tank for spray, and then even we can have the plastic feeder for the, plastic bead feeder here also, the control unit will be there. So we can use this bench for overall all the accessories towards the machine. Even the cooling system will start from jet cooling and whatever you say, timer cooling, everything will be placed on top of the stand so that we will have less problem. So that even you can have a space for even putting your casting bin or scrap bin here, so that the maintenance will be very easy. Suppose if we are not doing, then we will have a lot of problems and then maintaining these equipments. So this is a trimming process. This is a layout of what we are following it up. Anyway, I'll give you an example for that. So this is what we did it. You can see here all the equipments, whatever you have seen. This is an air tank for a sprayer, and then this is a heating line, and this is an oil chiller, this is a dye chiller, and even press or the press today total power pack is also put on the top of that. And then this is a plastic feeder unit. So all the things will be lifted above the machine area, above the side of the machine. And then these areas are all used for putting the biscuit and other things, slug and everything, we can keep it. So this is the biggest advantage of putting the layout in a different way. Then only we can able to maintain all these equipments. When maintenance, we can see they can go and attend independently, not having any. But here there will be a lot of cluster will be there. But maintenance approach will be more and more. Bottom machine is free from all this. So ground floor is free, so that we can approach the machine also very easily. Now, costing justification is just worked out. But anyway, I'm taking a 350 ton machine. Today market I'm putting it, but it's not a right market. What I can able to say that. So expenses will be around what I myself is considering, taking into account of power plus capital investment. The chiller and what I'm saying that oil chiller and the dye chiller minus the tower cooling furnace, that is the investment cost is coming. And then power cost, all put together 2 to 2.5 rupees is coming per shot. This is what already we got that some estimation, which we'll have to still refine. We have not run up to the mark of the production rate. We are in the stage of only PPAP and other things. But anyway, now the short rate I am taking it 35 rupees. Cost of chiller per shot is 70 paise or 2 rupees. That is cost of chiller. Expense shot. Probably this data is something wrong. I think so. Okay. Now overall rejection percentage is 5%. I am taking it. And then percentage of rejection porosity, 50% I will take. From the 5% shrinkage porosity domination is 2.5%. From the number of shots getting rejected per day is 60. So now I am taking the average shots is only 1,320 per day, but this is very optimum what I am taking it. And the number of casting rejections is around 33 per day. And then probably this will also include the machining rejections. Whatever I'm talking about, the machining rejection also is included 33. These are all only optimum, or even we can say minimum. From this, what I am calculating, it is coming 1,155 rupees per day. But the chiller running cost is coming around 924, around 8,000 rupees. Even if we make it a break even if any statistic data is there. So it is possible to implement this sort of, but that is a very, very clear. No urban cost seems to be positive. Net result seems to be positive or break even. However, the number of shots should be maintained to get a better cost results. This 50, even what I am talking about, number of shots per average number of, this should get increased. Then only this will get down. Since the unit is going to continuously run, so whether if you are making the number of shots is less or more, the cost per power of chiller and oil chiller will be almost same. If you are taking 1,320 or if you are taking 1,600, both are same. The energy cost is same for dye chiller and oil chiller. So probably we'll have to tackle this figure, 1,320 per day. You should go on more and more. Then your chiller power cost will get reduced. Add-on advantages are many, which are already discussed. Now, conclusion, what I am saying that chiller will make independent control on oil and dye temperature. This is what we expressed in the previous slides. Productivity is a key factor to recover the cost of chiller and power expenses. This you have to assure it, or you will have to make a measurement. The productivity is getting increased after induction of oil chiller and dye chiller. Then only you can able to recover the cost of power and as well as the investment of chillers. Our different temperature can be controlled by dye chiller, timer cooling, and jerkin, what we have explained to you that. And then improved layers is must to maintain the equipments near to the machine. Rejection can be controlled with the following equipments, chill in better way, dye chillers, oil chillers, and then I am adding it, oil heating and vacuum also. Independent dye chiller and oil chiller with the respective machine will improve the casting quality. The quality of castings overall enhancement can happen. Machining and consistency and above said all equipment provision and die casting machine. That is what I am insisting on that. Try to go for all the equipments and facilitation near the die casting machine so that overall quality of the rejections will go up and as well as reduce the rejections through process, not by skill. Thank you, man. Thank you very much. I will leave it. This is a time to ask for your questions. Main presentation. Yeah, please, any other questions, any doubts if you want to ask?
Yeah,
Good
please,
evening,
sir.
sir. This is
Good
Naveen
evening.
from NK, sir. Sir, I want to
Yeah,
understand if there is any tonnage limitation or tonnage economical calculation. Like, do you recommend going for chillers for lower tonnage of machine only, or you recommend chillers for higher tonnage? I understand it is still feature based, but what is your experience on this?
What I am saying that first time I am trying to actually yesterday I tried with only X factor. Actually, I could not able to reach that formula, and also I am making more convey that of If you're going for a more and more higher tonnage, you will have more benefit. What I'm saying that you can put this way. The chiller cost is some, say around nearly 7 lakhs, 8 lakhs. If you're going for a 1,000 ton, 350 ton, 7 to 8 lakhs. If you're going for a 1,000 ton, it will be around nearly 9 lakhs. Not it can be more. But what I'm talking about, your short rate of here 35 rupees will become there, it is 100 rupees. This is doubled. So now we can understand what will be the impact on costing factor. You'll have a lot of advantage if you're going for higher tonnages. And it is also, it is a must to have a die temperature control on higher tonnages since the cost of product is more. Cost of labor charge is very high. And one more thing, what I'm saying that remelting costs I have not taken into account. Say even if you maintain a 2% of rejection, once again the melting loss will be the melting cost and as well as the melting loss. Let us also get into the picture. Probably these are all the indirect benefits. So if you're going by higher tonnage, you know, the more weight of the casting, remelting cost is more, and as well as the melting loss will be more. Now, I think by transfer, apparently you can able to understand. For a higher tonnages, yes, there will be a lot of advantage.
Thank you.
Any other questions? Is it really useful to feedback? Can I give one or two people? Is it really useful or can we improve on this? Is it clear? My message is clear or not? Anybody can give feedback? I think I could be able to see many people. I don't think so. They are in the line. I will ask Dorairasan.
Sir, it's a very useful thing. This is Bakul from BMW Auto Components.
Yeah, please, sir.
The whole presentation was very useful. My one concern would be for lower tonnage machines alone, where we have the maximum tonnage of up to 400 tons. Like you said, the cost feasibility for going below 350 tons is really a thing of concern.
No, it is what I am saying that
Not
that is
justified.
that's why I am telling that I have taken that 350 ton short rate only for presentation.
Sure.
Almost it is coming at a break even. If even a little error is there, it is coming in. I mean, why I made this presentation also, there's one more thinking is there. Since I have provided in front without knowing the cost and all that, by seeing that this is going to be the technology, we'll have to bring it inside of the die casting. That's why I made that. But I want to justify whether the costing is getting satisfied or it is meeting that real. What I thought of it, that is why we evaluated the costing factor also in this slide. But I could be able to see there is a break even is happening in 350 ton machine, lower tonnage. It is happening. It is happening.
Below 350, it is not feasible.
Not like that. Below 350, how much shots you are going to make it? Sir, what I am saying that you will put this
Typically,
way,
120 tonnage.
yeah,
we can
120,
go
what
up
I
to
am saying,
about
what is
80,
your,
sir.
what is your roughly around labor charges for 120 ton? If you are making around nearly 600 to 700 shots per hour?
Sir, per day, per shift.
Per shift.
Uh,
Then I will put this
labor
way.
cost
You
would be
can verify with
around
that.
1,200.
You put this way, I am putting that apparently whether the shorter. What I am saying, the labor charge is what it is generated in 120 and generated in a 250. What will be the percentage of difference?
Probably
Second time,
120 ton labor charges would be 5%
You
lesser.
just-
That's all.
That's all. So you just imagine what is the turnover you are going to make it in 120 versus 250 ton machine. Why I'm talking about, even if you go for 350, your number of shots will get reduced because of certification time and other things. So normally what I could be able to say, even the 120 probably will have to work and see, you have to work and tell me. In 120, I think it will be more feasible. If you
No,
start
but overall
tackling
short
that,
cost is lesser, no, sir. The short cost is
Overall?
1/3. Short cost is 1/3 of 350.
Hmm.
So there you will get the productivity will not be 3 times of increase, whereas the short cost will be 1/3. So there the break even will not work.
Now
So
I have
it'll be-
taken only around what I have taken in the slide is only around nearly 60 shots per hour
So-
and 22 hours I have taken it. So same thing you can take. What will be your hour rate in 120 ton machine? Short rate. Around you will take 80 or 100. Even I could able to hear that some people are making 100 or 80 to 100.
So say,
Number of
okay,
shots per
100,
hour.
100 shots also you go and you charge
Hmm.
about 12 rupees to 14 rupees a shot, 12 rupees on an
Hmm.
average. So 1200 rupees.
Hmm.
Whereas
Here,
on a
350,
350,
60 into 35,
16 to 35. So that is,
1800.
Yeah.
Roughly 1,800, 2,000 rupees. அவ்வளவு கூட வருது 6 12 6 3 1500 rupees. Am I right?
yes, sir.
1500
2,100
again.
rupees, sir,
Which one? 35 into 60.
is 2,100.
35 into 60. Ama. 2001. Here it is 1,200 rupees, no?
Yeah.
1,000. So 50% is coming. Right. Is there any possibility of, suppose if I could able to put a die chiller and other chiller biscuit, I mean, when I increase the cycle time to up to 150 or 170, or I mean, around nearly 125?
We can try, but see, on automation, we can probably try and push like that. But when you do it with the manual setup, then there is a challenge on consistency.
Well, I could not able to understand what you are talking about, that you don't have the auto ladle.
இல்ல, 120 tonnage generally would not have auto ladles and automation. So in that case, consistently maintaining at 120 shots would be difficult. There'll be a little fluctuation.
Yeah, you have to add that auto ladle. It's a basic note today. Probably you are running with a different
Yeah,
scenario.
so
Different
250 and
scenario
above
is
generally
different
has
actually.
auto.
But that is why I'm telling that today, I told in the marketing, what people are expecting it, even for a long term, you should have a process. You should set the process, you set the shop floor, see that de-skilling is inside. You should not put the process in such a way that it is a man dependent. It's very dangerous. Then it is very dangerous in the means in the future what is going to happen. Everybody knows that because of the de-skilling or other manpower will be a big criteria, and you will be also facing the problem. Suppose some people, some 120 means 3 or 4 operators are selected and then they will be only running that. But how many days it will run? So challenge is different today. Probably running is today is, I mean, successfully is different, but what way of working? That is to be taken into account. That is to be taken into account. Probably it's okay. That is another part what I am saying that. But anyway, what I am telling that you try to make 120 ton machine. Suppose you are having a 120 and 250, connect one die chiller, one oil chiller. Then you are already having a lesser capacity, no, an oil tank.
Right.
That is possible. No, 2 machines can interact with that. No,
Yeah,
feasibility is there.
that will make the feasibility better.
Yeah,
True.
better. That's why I'm saying that. We have to see the feasibility so that it will come inside.
True, sir. That can work.
That is possible. So that is not wrong. Big machines only need an individual and all that. But a smaller machine, we can have a common die chiller and common oil chiller. So that one more possibility is that you can increase the cycle time. But provided you should add this auto ladle and all that. Okay. That's another criteria. But it has to be debated in a different way. Making successful, that's why I'm telling die casting people what I'm saying that I used to say my shop floor also, die casting people are not having a restless night. Always when the call will come, nobody knows. Especially supervisor side, I'm telling that. They are in the very, I mean, even I worked as a supervisor at that time, even the night call will come and then I will go and do this and that. Probably I'm not doing much, but anyways, giving some guidelines, this and that. But these are all used to happen. That is why we'll have to set the process in such a way it should run, I mean, without any much difficulty inside. I'm not saying it will be 100% will be eliminated, but at least you can reduce the frequency. So you set the process in such a way people have a, when peaceful. Probably today, Any of the supervisors will be only hired from the outside and they'll be employed here. They should have they should also have a good life. Or suppose even why the one more engineers are not coming into die casting. Why the problem? Anybody can give some suggestions. Why the engineers are not more attracted by the die casting today? Since your process is still it is in a primitive stage. Now from the lathe, now it has come a CNC lathe. The CNC lathe will come into an online control. From the online, people can work on the table and control the machines or control the programs, control the production, quantify the production in IoT. But today in die casting, what they can do, every engineer has to come into shop floor. Then people finding it difficult. No, probably we will have to make the facility in such a way that people should work conveniently. I'm not saying 100%, probably that 80 to 20 will be there, but 20% they can go to the shop floor. At least most of the time they should work on the office. So your process in such a way should be maintained. They should work for the Kaizen. They should work for the improvement. They should work for that data processing. Then only engineers will come into picture. But today the die casting floor is finding difficult in gaining the engineers inside the shop floor. This is a true fact what I listened since I am also in the line of 40 years. So why other people are not coming in? Even my classmate has entered in Enfield for some time and then he went away. And what is the decision he has taken? No, he has taken the LIC license and he is doing very well. License work. So my classmate, what I am saying, engineering mechanical graduate, after seeing that die casting at that time, what I am saying 20 or 30 years back. So he went into die casting shop floor and then get away from that. So probably the die casting fraternity should think bringing the engineers in such a way that the shop floor and as well as at par with the CNC shop floor. At par with the CNC shop floor. Then probably people will start coming in. Yeah, there is a lot of opportunity here. Any other questions? Any other suggestions?
I think I don't think so. Any other questions are there? We'll close the session. I really thank Prabakaran sir for the beautiful presentation, and I really thank all the people who actively participated. And personally, I'm telling Prabakaran sir, this what we have a bigger mission, LK 1250, LK 1600. 1600 and 2500 and 4500. So most probably I will get in touch with you, and we have a bigger casting for Ericsson and Nokia for 5G products, and we have some the casting weight is somewhere around 11 kilos to 12 kilos. So maybe I will be in touch with you, sir, and it's a very fruitful webinar we had today. Thank you very much. Thank you all for joining.
Thank you, sir. Thanks, sir.
Thanks, Prabha sir, and thanks, Yuvraj sir.
Yeah,
Thanks,
please.
Durai sir. Thank you, sir.
Durai.
Yes, sir.
Okay,
Yes, sir.
Thank you. Thank you, sir.
Thank you, sir. Thank you, sir.